Okay, so welcome team, session 14, I guess, of the GenAI training. So we are almost towards the advanced topics and project assessment and project assignments and use cases. Um, so I guess you all have enough context now, comfortable with the GenAI architecture, models, landscape, and building applications with agentic AI tools, and the RAG architecture and everything. So the next part, what you need to focus on is doing some hands-on and building use cases. So tomorrow we will also talk about some use cases, basically use cases in the sense, hey, where do I need AI? Where do I need agents? Where I don't need agents, right? So that we will talk about. We'll talk about guardrails, and we'll talk about doing projects and all of that. So today we'll talk about the MCP, Model Context Protocol, that's coming new. You can say it's a new standard that is getting adopted in the AI world for building all the AI agents. So before getting into that, can anybody summarize what an agent is?
So an agent is like which needs tools based on give the information based on the knowledge it has, and it's supposed to have some memory to keep that knowledge and the tools how to use and all.
Right. Yeah. So an agent basically has a memory, a model, LLM, and tools, right? So tools are basically to address the limitation of a model to connecting to the external world or the internal organization to retrieve the data which it is not aware of, whether current affairs, current data, latest events, or internal data, organization internal data. So that's what we learned, right? Now, when we do that, how are we providing the tools? So each tool, a web search, we are creating a tool. If there is any other tool that we want to integrate with, again we create another tool, and then we get it, we use the integration to add to the model, right, the agent. So there are a set of tools, so each tool we interact separately. Okay, so that's how we do it. Now when we talk to any tool, the standard, like what is the input and what is the output, is pretty much different, right? Each tool is different and each way of communicating with the tool is different. Now to address this complexity so that you don't get complicated about talking to multiple tools, you create your own integrations with each tool and communicate with each tool. So this become like a standard. We want to define a standard where everybody align to that standard. Okay. Now, for example, if you take REST API, right? So REST API is a standard for HTTP is the standard protocol to communicate regarding REST API. But of course, each input and output is defined, what is expected. So you have REST methods, get, post, or whatever. So that is the standard method of writing your integrations, exposing your data or serving your data, right, over the API. So the same REST API. So everywhere, wherever you use, if you want to use REST API, you have the same standard template that you need to have a HTTP protocol, and then you provide a request object with authentication, authorization, and all of that, and then you have kind of you want to build a request body parameters and the query parameters or the request body, and you send it over to the server or whoever is wherever is the rest endpoint that is exposed. and then you get the response back. So that is the HTTP standard. Now the same standard we want to define for the agentic world. Okay. So how does it look like when you define the agentic world? Let me share my screen. And different here I'm not able to merge, but let's go through this. Just share. Okay. So what it does, MCP protocol, the architecture is okay. Let's use this one. So we know this, right? So we have an agent has tools. That's what we're talking about, and then it has APIs. Okay. And then it talks to the model and it gets the information, provides to the model, and then model takes a decision. Okay, to make another API call, or do we have another we have enough information. So that's the model using the tools to get to call the APIs. So each tool has its own APIs. So each API we know with different behavior, different authentication methods we talked about, different request schemas and response formats. And then it
Hey,
needs custom.
Arun,
Yeah.
sorry, Arun. In the previous slide, when you say
Mhm.
tools, basically what you're saying is, the AI system itself has their own operating system, own, developer tools that can be used to create that agent, correct?
No, here, sorry. So the context here, everywhere when we use tools like we talked about, right? The agent has three parts: the model, the tools, and the memory. So this is referring to that tools. Tools is basically uh, like
Okay. So
the
we are
research or search
expanding
API
on the
search.
tools.
Yeah.
Okay.
Yeah.
Okay.
Yahoo Finance tool connecting to Yahoo Finance and all of that. Wiki tool. So those are the tools we are talking about here, right? So, so every integration, you have to do your own custom code for the tool, custom parsing, custom error handling, and all of that. So now when MCP arrived, it became a standard universal translator, standardizing the communication between your agent and the server. So all tools exposed a uniform interface, consistent schemas, and predictable responses. So basically, what happened was you are building the server, you are building the tool to connect to a certain resource, okay, internet or whatever. So you have a web interface, you write your own tool, and then you connect to web interface. If you want to connect to a database, you write your own Snowflake connector, and then you create as a tool, and then to connect to the database. Now in MCP, what's happening is the target or the server who's giving you that information, they will create a server and they will expose their services, just like REST services. They will expose their services on MCP protocol. They will expose as tools. So when you access that MCP server of any provider, it will give you what are all the tools available, and then it can communicate with those tools automatically, any of those tools based on your request. It will translate, and then it will get you the information from the server on the provider side. So just like agent, MCP also has few components that we will go through. Okay. So it standardized the conversation. All tools exposed a uniform interface. So now you will not write server. Of course, you will write servers if you want to expose your data or so resources. But the third party, let's say if I want to connect to Yahoo, so Yahoo will provide an MCP server. Or if I want to connect to Snowflake, Snowflake will provide an MCP server. And if I want to talk to or connect to, say, Airbnb will provide a MCP server, or hotels.com, they will provide a MCP server. Now, it's a server there. So we will become the client, which using the MCP protocol to use that server tools. Okay. So we can add that MCP server to our environment. And then when we invoke those tools, it will automatically connect to the server where it is running, and then it will get you that information. So it no longer need bespoke connectors. It simply interacts through MCP, which handles the translation, validation, and safe execution across every tool. Okay. So what it does, it's a standard protocol that connects AI models to external tools. So please remember this. I mean, whenever they ask at least high-level definitions, right? So what is an MCP, right? So you have to understand what it is actually. It's not a model, or it's not an agent, or it's not something like that. It's a protocol. It's just a standard. Like, you can give this analogy. It's the same HTTP we do for REST API. It's the same thing, MCP for agentic AI, for agents. It's a standard way of communication of agents with external world. So all the MCP servers, all the providers are going to align to that standard to expose their tools, their services through the tools. Okay, that's the MCP protocol. So it's a standard protocol that connects AI models to external tools. So AI models here is whatever the a model that you have within the agent, right? Whichever model that you are using, that data sources and enterprise systems in a secure and structured way. It lets agents pull real-time information, execute actions, and interact with apps or APIs without hard coding integrations. So you don't have to hard code an integration structure, right? This is the request object. These are all the parameters and all of that. So it will intelligently, of course, we have an agent, we have a model that can take care of based on what the tool is expecting. It can build that, align to that request for that tool. Now, it ensures consistent, safe, permission-controlled access to tools across different models, teams, and platforms. So it's make it easier to build reliable GenAI agents that can operate inside workflows, products, and corporate environments. It supports scalability, auditability, and interoperability, all of those standard, for any platform that you want to use. This was actually introduced by Anthropic. The Model Context Protocol is by Anthropic. There is another protocol called A2A, Agent-to-Agent Protocol, that was provided by Google. So these are the two latest advanced developments in the agentic AI. So that is standardizing the architecture. Okay. So because we are here, we'll talk a little bit about it. So while MCP, Model Context Protocol, allows agents to talk to the external servers with tools to access the tools and get information, A2A protocol is a standard to communicate between the agents. So one agent to other agent, how do they communicate between them? This is from agent to the MCP server or to the tools using external world, that is MCP protocol. Now the communication between the agents, within the agents, is going to be using A2A protocol, agent-to-agent protocol. Okay. So now let's come back. So we'll spark at it. We have not yet there the A2A protocol yet. At least MCP is like having huge adoption and building servers and all of it. So let's see. So what happens is MCP an agent? No, MCP is simply a standard, a definition. There is no component as such for MCP. So I will show you. It should have. Okay. That's why I'm trying to switch. It's not able to console. Yeah, I'll show you the components anyways. Let's see. Every agent has, it will load the mcp.conf configuration file. So each agent will load the configuration file to understand what are all the MCP servers that are available, which means just like we are registering the tools to agent, here we don't have to register the tool. So the agent will know from the configuration file what are all the MCP servers available, and within the servers, what are all the tools available. Okay, the file defines server endpoints the agent must connect to. So this is where the file will tell the agent where this server is running, right? The external server where you can connect, and it's like an endpoint where you can connect and get the information. The tool manifests exposed by each server, which means what are the tools that are exposed. Request response schemas for all operations. I don't think we could define the schema, but we'll see. Authentication parameters that needed to connect to that server. Capability rules, allowed methods, rate limits, all of that you define for the communication. So once loaded, the agent gains a standard schema-driven interface to all tools, eliminating custom integrations. Okay, so all of that is defined in the MCP configuration file. You can add as many servers you want the agent to have that access to, and then it will load and it will know all the file. It will know all the servers where. See, example how the configuration file looks like is kind of this. So this is a MCP server for MongoDB. So suppose you have a MongoDB running somewhere, and you want to connect to that MongoDB and get information. Now, how do you rule in a standard general in our own world, traditional way? We use connectors, JDBC connector or a MongoDB connector, and then give authentication connect, and then write queries and cursors to execute and get information and all of that. So that's to get the data. However, if there is a MCP server that is exposed, okay, for your MongoDB and the tools that you have added to that server, right? And that tool will define all the queries and everything is written on the tools. Okay. Now, if you go there, how do I connect? The agent connects to that MCP server is a command. What are the arguments? MongoDB is a connection string and all of this. So using this, it will expose, hey, this is the MCP server that is added to the agent. And when you go to the agent, it will have all the tools that are available for this MongoDB. So how does the model work in a client server model? Okay. So what is your client? Client is your agent. So of course, even before a client, you will have a host. Host is your ID. Let's say you are using Visual, so VS Code or Anthropic Claude, Claude Desktop, right? Or any other Cursor ID, anything that is your host. Okay, wherever you're running. Then it'll have a client. Client is your agent. Okay, or your Claude agent. So once you have this client, it talks to the multiple MCP servers. Okay, all of these, each MCP server you have added. So all those servers will be available to the client. And each server will have its own tools that it can talk to. Okay, so when you put the request, it goes to the agent, and the agent has, say, model, any model. So the agent can, using the model, decide which server to connect. So it has connection available to all these servers. So it will decide which server and which tool it has to use for solving this request. So once you get that, then you send back the response. So once you get the response from server, is again validated and see, hey, is it a good answer, or do I have to go back and ask for more information or call any other server? Okay. Now there is another agent So there can be another remote agent that you want to connect to. So this can delegate to this agent, and this agent has different MCP servers available. So that is also another architecture in the multi-agent platform that you can use. Okay, for now we will stick to this one agent and how you want to use MCP servers. So as I said, this is another protocol when you have more than one agent. So between agent to agent, it can be a agent to agent protocol, A2A. So provided by Google. So this agent talks to this. Right now also we have, right, when we have done Crew AI or we have done Langflow, we have multiple agents and we know how they talk to each other is managed by the supervisor agent or the Crew AI or the crew manager, or we call it crew, right? So that is there. But here what happens is each agent will showcase their flashcard, their capabilities using a like just like a visiting card. So it defines a standard communication layer for AI agents to interact with each other and with tools and services. It uses structured messages, requests, actions, observations. It supports capability discovery. This is the important part where agents advertise what they can do and how to call them. So the agent will give out their flash card or the visiting card, says, "Hey, this is my name. I'm this agent, and I have all of these capabilities. I have these tools, and I can do these things." So that is that capability is advertised. So the other agent, they read that, and then if they need any of those services, they connect to this agent and then call them, saying that, "Hey, you have this tool, you can do this, so please do this for me." Okay, so that's how they interact with each other.
Yeah, Arun.
Yeah.
So, this is a very similar concept, right? I mean, MCP, I understand, is from Anthropic, but then, if you look at, just taking my own the examples that I'm exposed to, right? If you look at Oracle or SAP, we have our own SAP AI Core or SAP AI Hub, where we where we provide tools not only to develop agents and have that A2A or agent to agent interaction with not only just one large language model, but you basically you can interact with a marketplace for large language models, meaning a customer who's using SAP and SAP AI Core can actually create their own agents, right? And a supervisory agent through the developer kit that is provided there, and they can access other large language models in the marketplace, and they can create this complex web of talking to agents across the SAP modules, basically, right? Is it also as it is? Can I also call that as an MCP server or a similar MCP landscape?
No. So see, there are different ways of communicating, even without MCP also. Right. All of these 13 sessions, we were still using tools, we were still using agents, we were still using multiple agents, but we have never used anywhere MCP or A2A protocols, because we were doing the crude way, like, not, I won't say crude, but traditional way of using a tool, registering it with the model and the agent, and the agent using that tool, and then we define the input and output within that task the tool can use, right? So this is like, let's say, talk about REST API. So without using REST API, HTTP protocol also, you can integrate using JDBC or something. You can go and get your data from the tables. The same thing, you can create a microservice which reads the data and gives you back response, and you expose it as an endpoint. That becomes your standard way of communication, REST API. Because every client, they have to connect to the database to get the response. But here you are putting a gateway that, no, you connect to the endpoint, we will talk internally to our database and give you the response. So that's how the microservices or the REST API is structuring the communication with more control. The same thing here, you don't directly go and connect to the resource, rather you connect to the server, which is provided by the vendor. The server will take care of communicating with its internal resources and giving you the response. So that's the standard. Now, if you're talking about, yes, we are connecting to multiple models, connecting to LLM model is still on the REST API. You're still using API to call a model or to get a response from a model if it is wherever it is deployed. But you connect to a tool or a MCP server, you use the MCP protocol. Okay, the moment you define a MCP server and register it, it will automatically use MCP protocol. Same thing, if you have multiple agents, you enable the A2A protocol, or by default, if it is enabled in your platform or whatever framework that you are using, internally, it uses the A2A protocol. Let's say we have multiple agents, but the agent wants to delegate something to the other agent. So that's when it can use the A2A protocol and see which agents has capabilities to understand, to go through and do this for me, get this answer for me. So it kind of delegates that work to that agent based on the flash card, the agent card. Okay. So it kind of similar, but MCP explicitly you provide MCP server, only then it uses MCP protocol. If you directly register your tools with the agent, it just uses the normal REST API or API, whatever it is, the tool is built on, it will use the same thing.
So Harun, so each, say example, Yahoo Finance, it's their responsibility to enroll or have the feature of MCP server for exposing to agentic AS. Whoever wants to connect with that. Is this right understanding? Okay.
Yeah, so it is, but see, there are three things, right? Let's say if you take Airbnb, they or hotels.com, or let's say United Airlines. If I want to book a flight, there are n number of ways to do it. Now, if you want to take agentic AI route, United Airlines can create a MCP server where it can expose tools like get flights, show vacancies, or book a flight, all of those tools, just like REST operations, get, put, post, each endpoint as a tool exposed on that side. And I can just take where the MCP server is available, connect to it, and then you do it. That's the A2A protocol. Now, let's say United Airlines has not provided that. There are some third-party agents. So that's what is happening right now. Third-party people that are creating these servers for you, like they implement that solution. The complexity of you connecting and scraping their website or calling their APIs is taken by them. They will do it and expose it as a MCP server. So use third-party tools, and then you can do the same thing. Of course, it's the same thing, but it's not directly given by United Airlines, but it is given by a third party who's doing that work for them. And the third way of doing it is you implementing the MCP server yourself, using their APIs. You can build your own tools and then create a MCP server and then attach it. So the three ways of doing it. Okay, so we will go through it. I will show you how each kind of way of creating those servers. Right. Google Cloud, it's partners contributing to agent protocol. So this is how A2A protocol works. Like agent, it will send a task to remote agent. If it needs info, it requests more info, additional info, send synchronous updates and final response and artifact. Just basically to and fro communication between these two agents based on the defined protocol. Okay. So let's stop this here, and I want to go and say, So this is what Anthropic does. Okay, so you have specifications and SDKs here. For the model context protocol. Go to documentation. So this is how it works. So anything your application can be a client, cloud desktop, IDEs, other AI applications using MCP protocol. They connect to any of these data sources and tools as these are the MCP servers. Okay. So you can go through this documentation for further. So you have servers, clients, so this is what MCP client you have one-to-one connection each client with the MCP servers. So this is your application. This can be your IDE, and your application is your client, each application, and then each client that connecting to the servers. Okay, so they have all of this, how this protocol works, like transport layer, data layer, all of this you can go through. Basically, this is also important to give it a read. STDIO and streamable, these are two important things. Whenever it's an important question, people might ask when you talk about MCP. So basically, it uses STDIO uses standard input-output streams for direct process communication between local processes on the same machine with no network overhead. So this is, if it is running on the same machine, use STDIO transport. It uses HTTP post for client to server, enables remote server communication, and supports standard HTTP authentication methods, tokens, keys, and custom headers. Okay, so these are the two transport mechanisms. You can read further about it. There's some kind of documentation if you want to know more about it. So you can load. So what does the MCP server has? So server has three components: tools, resources, and prompts. So we know tools, basically this is what we are using, executable functions. Each tool has a function that it achieves and gives you the information. Resources is the data, actually the source of the data. Like if this tool is connecting to a database, the resource will tell you what is the database records the actual data and all of that. Prompts, we know, just the template, we write the prompt and leave it so that if any of the server tool uses a specific prompt, and the server itself can expose that prompt that we can use to connect to that. Okay. Each primitive type, all of these are associated with these methods for discovery. So one, you can get all the list of tools, then you can choose which tool you want to use and all of that. Okay. So something that you can go through this. You have everything about servers, you have about clients, what are your clients, all of that. And also the architecture, if you see here, user asks a question. So this is the user, this is the client, server initiates, so server elicitation, then if you need human interaction, then complete the request and then send it back to the user, the client. This is all the holiday booking approval. So you can go through it and use it as an example. So we can come back to it once we do a quick tour of how to use MCP and all of that. Okay. Now here I have a project. Any questions before we move into the demo part? I will do simple demos, not very complex. We'll build one MCP server on our own, and then we will also use Claude to add some MCP servers and check that. Okay. Any questions?
Yeah, I have one question again. So tools are not developed by us, it's developed by some other company. Like we are going to the interactions, like API invoking, right? So it's another form of API calls like that. Can we think?
Can you come
MCP,
again?
the MCP calls and all, is it similar to API calls, right? We are calling
Yeah.
the tools and then it's getting the response like a client server
Yes.
model, right?
Yes. Yes.
In case of agent to agents, it's within we only developing. So agents, both agents we are developing. The communication between the agents are used A2A protocols, right?
Yes.
So whatever agents we are developing, whether it's LangChain or LangFlow, they are all using A2A protocol within agent communications.
Yeah, so I think it depends on the framework if it is enabled all the agents. So right now, internally, that communication is happening within the framework using APIs. But if they are using A2A or not depends on if the framework is enabled. We are not writing that protocol that yet. Okay, so I will explore and then I will get back to you with an answer how to implement that protocol with the
if you're using protocol, then there will be some advantage, right? Like MCP, there is advantage over API calls, right?
Yeah, exactly.
So
yeah, definitely. So this is intra agent. So from agent to the external world, that is inter agent, like within the agents. Intra agent and inter agent, right? Okay. So what we are doing here? So I'm just showing you an MCP server. If I want to write my own MCP server, all I have to do is import mcp.server.fastmcp, which I'm calling it weather. This is my MCP, initialized MCP server. Okay, MCP server. And I have this URLs, endpoints, basically to connect to these URLs when I create the tools for this MCP. What are these? I'm make NWS request. This is a method, a syncdef, which takes the URL and gives a dictionary. Make a request to NWS API with proper error handling. So this is the standard boilerplate code to connect to any URL, right? For this, and then get the response from this. Now, what this is using, it is using this URL that we pass. Okay. So where this, when I'm creating, so these are the methods. Now here, I just declare @mcp.tool. So this will become my tool that it can be exposed in the MCP server. It says get alerts. It takes state code as the string. Get weather alerts for a US state. Arguments 2-letter US state code, CANY, like this it takes. Now the URL is, we are using this base endpoint, weather.gov, okay, / alerts active area and the state code that we are giving. So it will call this function with this URL and the data is what is returned. Okay, and then there is a resource. So we talked about MCP servers has 3 parts, right? Tools, resource, and prompts. Okay, so this is the tool and this is the resource. The resource will echo. Here we are only implementing just to echo a message. Okay, whatever message we get, we just echo that message as a resource. So normally it will show all the resources that are available there. Okay. So this is the simple implementation of a server if you want to write a server with a tool. Now, how do I integrate this or implement this with the MCP, right? So what we can do first is there are 2 ways. One is the MCP inspector. First, we want, it's kind of a checking whether how my MCP server is working or not, what are all the tools exposed or not, what is not available. So first we can do a inspector. So what we will do is you will say UV run MCP dev server and MCP dev where, so we have to give this path, the server / weather.py. So once I run this, okay, so it will, it's kind of a swagger for you to check the APIs, right? The same thing here. It will bring up the server with the local MCP inspector, okay, localhost 6277, and it brings up this. So here you can see transport type is stdio, command is UV, and all of this. Now you can say connect. So it is connected to that server now. List resources. So we don't have here just the message.
So it's connected to MCP server, right, Arun?
Yes.
Okay.
It's connected to MCP server. If you see here, you have any prompts, it will lift prompts. Tools, it will say list tools. See, this is the tools that are available. Get alerts. So this is the same tool that we have exposed here at MCP tool annotation. Get alerts. Okay. Now, if I do this, get alerts. Selected this. Now it says get weather alerts for a US state, 2-letter US state code CANY. And then I would say go to get me for California. So just check run tool. And then see, these are the alerts for California. Okay, dense fog advisory or whatever, all of this is the so this is just the testing part. Now how do I get to run the server, okay, and integrate with any of the clients, okay? So I will stop this.
And Arun, what is the use case here? So we are plugging into the weather channel. Just getting the weather. This becomes a very standard AI use case that we have seen before. From an MCP standpoint, we have to do something more than this, right?
No. See, it's not that we are doing more. It is you are just doing in a standardized format. This use case may be simple, but you are using the same. See, it's like connecting to a database directly through JDBC string or connecting through API, calling the data, get information. Okay, so this is the standard way of using MCP protocol to connect to a resource. So this is the MCP server that will be running and giving you the information instead of you directly going and scraping their website or using their API and all of that. But of course, server also
So I can have a use case where I say I call not only weather.com, weather, I guess, is it, we just connected to weather.com here, right? To get the California weather?
Yes. So
right.
it's running this tool, right? So when it runs this tool, it is calling this API, REST API method, API base with this state code. Okay. Now what is this? Where is this going? It's going to this HTTPS API weather.gov.
Right.
Okay.
So I could use a use case where I also use Airbnb, meaning I add Airbnb to this, and then I say and the system now knows that, and I'm looking for something in California, and behind the scenes it is also looking at weather.gov, and it's saying that I understand that you are going to California, but I also know that weather in California has, say, this particular section has fire hazard or whatever, then it can give me some positive. I mean, it can give me a result which combines all of these things.
Yes, it can. Yes. So those are two different
And this
MCP
can be
servers you
done,
can
and this
connect
can,
to,
yeah, and
and
this
it
is
has
done.
all the
Sorry,
tools.
yeah.
So it has a weather tool, it has Airbnb tool. So based on what you want to know, your use case, your question, it can use both the tools, both the servers, and combine it and get the information. Yes.
Okay, and in the without MCP, I'll have to do that manually, meaning I'll have to call both of these places. Even if you
Yes.
take this as a simple case, then I have to call both these places and then have something stitched together for me.
Yeah, it's not like that. Basically, that is also can be achieved. But yeah, so you have two different tools. So you have to create two different agents. One agent for the Airbnb, one agent for the weather. Of course, that is also a good way of orchestrating, and another supervisor agent. So again, the agent will call both these individual agents based on your questions. It will split. It will get information from both the agents and then it will combine it and give it to you. That can also be achieved. But with the MCP, okay, it's a much cleaner and standardized way of doing it.
Got it. Thank you, Arun.
Yeah. So let's see the use case now. Yeah, somebody asked, UV is just running this method. It's a new. It's just like you have a poem and pip running for the Python applications. Okay. Once terminate job. Oh, what happened? Oh, you should have said yes. No. Okay. Now, if I go to Claude desktop, my Claude desktop, okay. Now I have here something called search and tool. So this is my client. Okay. Now I can add any of the connectors to this. You see here web search, drive search, Gmail search, calendar, Airbnb, and all of that. So you go to manage connectors. Okay. And if you see here, there is weather local dev. If you say configure, you see here what are the tools. Okay. Now let's go uninstall this, disconnect. Remove. Is it remove? Close this. Oh no. Claude desktop. Go here. File. Exit. Okay. So now you see, I don't have the weather app here. Okay. These are the other ones that is already added. Airbnb. I will show you. So if you go here, extensions, browse extensions. So these are all the already available MCP servers that you can add to your Claude desktop readily. Chrome, Windows, desktop, control your Mac, Postman, Airtable, AWS API, right? So if you ask your question, it can connect to any of these sources based on the configuration you give. Okay. So if you have a Tableau dashboard or Tableau BI, you have a connection string user, you add this, you can run your Tableau dashboards right from here. You can give a question, it can connect and then get the response.
Yeah, last 20 seconds and your voice were breaking. Could you please repeat?
Is it good now?
Yeah,
Yeah, it's better
fine.
now.
Okay. So this is like desktop extensions, and web extensions that you can use, third-party MCP servers. Like say, if you want to connect to a Databricks, you can directly add this here. And if you can directly run your Databricks jobs or queries from here directly, it will connect to the MCP server and get you the thing. So these are all the, sorry, you have to get server URL and then get this auth and then paste and continue. So these are readily available ones to add. So okay, we'll see how you want to add these servers. Now, if you want to add a custom connector, add custom connector. You can also add name and report MCP server. We can do here. Okay, and then in general, connector. Advanced settings. So these are all install and uninstall ones. Okay. Now I want to add my local server that I'm running, which is my weather app. So I can actually do it directly from here. So all I have to do is UV run instead of dev, MCP instead of dev, I will say install. So once I do this install, okay, so it will say add server weather to Cloud config, successfully installed weather in Cloud app. So this weather is now installed in the Cloud app. Now, where is that? If you go to there's a Cloud config we're talking about, right? So here, the file has been modified by another program. Say yes. So if you see here, so this is the entry that was added to this configuration file, Cloud desktop config.json file. When I run that command here, okay, so it will automatically go and add to this configuration file. This is the entry. So it will tell where this server is running. See here, this is the path. Okay, uv.exe. Forget about this Langflow desktop. Somehow that got created. That's just the folder name. Don't worry about it. UV, where the UV is installed to run. And this is the actual server to your, path to your server. MCP demo main project. Server in the server folder, we have weather.py. So this is the actual path you run. So when you run this, your Cloud desktop is here. It will automatically get that weather.py. Now let's see, go back here and see if you can see weather. So you still don't have weather MCP server for the weather, right? Do you see here?
Yeah, we don't see it.
Right? Okay. So let's restart this and see if he's able to read the configuration file and load it. Okay. It on the startup, it reads, right? Generally applications read the config files on the startup. So when I start the application, go here. Okay. See now, weather has come. Okay. And then you see here, if you click on that, this is the tool. So if you have multiple tools, it will show multiple tools. Okay.
So Sayed,
Now,
here the tool command all the information you added in the config. So when you're starting, it automatically run the command, it invoke the tool as well. So if both are independent, for example, the tool is running separately, and then you want to invoke that into your
yeah, so
into
that there
your
is
code.
no, I didn't give any information about the tool here. I gave only about the server. So when this server is running, when it will go to connect to the server will expose all the tools that it has to read. So it reads from that server when it is connected. So this is what you have actually put here as a tool, right? MCP tool. Get alerts. So this, it reads, okay, all of these tools and it connects to the server and it exposes here. Okay, let's see here. What are the weather alerts for, let's say, I want to say Florida. Okay, run this. Now see what Claude does. See here, Claude wants to use get alerts from weather MCP server. So it has detected and it found that there is an MCP server called weather, and then there is a tool called get alerts that it can use for this particular query. And it has also performed what the request body should be for that particular tool. So we have mentioned that the tool will take a parameter called state, but it has to be a 2-letter code. We didn't give any 2-letter code here. We said Florida. So it automatically converted and built that input for the as per the tool. So that's what we were saying. It will standardize. You don't need to worry about how I have to send the input for each API, how I have to send for each tool and all of that. It will automatically build based on what is expected. It will build the request to send it to me. Then we have given here human in the loop. So you have to actually allow it to use that tool. So let's say I allow once, then it will go and get the alerts for Florida. Okay. So this is how our MCP server is running, and it is invoked and the MCP server connected to it, and then it is working. Now let's go to the MCP itself, right? Say go to community. Servers. See here, MCP servers repository, list of MCP servers maintained by companies for their platforms. So this is what I was talking about. When the companies are building companies are building the servers to expose their services. Earlier they used to do, see, first when you want to book a flight, all the travel agencies used to scrape their website pages and get the information. Now what they did, the flight companies, they saw, hey, this is useful to us. They said, hey, don't scrape the website and do all of those complex logic of extracting information from the tags and all of that. We will give you the API. So they provided API, and these agencies from their website, they call the API, and the flight companies like, American Airlines, United Airlines, they'll give you all the flight details, booking details, price, everything that displays on your web page when you are using a third-party agency, just like booking.com or whatever. Now, the same thing now it's for the agentic world. Same providers are now saying, okay, if you are using agents, now These are our MCP servers. The same functionality is now exposed on MCP server, and these are our tools. So you can use these tools with your agent to get the information. Okay, with the new platform, the same thing that now they are providing through MCP servers. So these are all the ones that are done by the companies right now. And there is a lot more support gaining in adding. So AstraDB, they have given their own data stacks. They have built their own MCP server. So now they have a tool. You can connect to AstraDB and then get information from there. That is one use case that you can implement and see. Okay, and all of this. Now, if you go, Chroma is there, DevTools is there, right? These are the current ones. Have we crossed over? Yeah, sorry. Just these are just the third-party servers. It's official integrations. Okay, that are done. Couchbase, Labs, Cisco. Everybody is now building for the agents. So you can use any of these servers. Okay. Microsoft Teams, MuleSoft, all of those. These are all the agents that are already available for the third party. Okay. Now, community. Okay, these are the third party ones. Those are official integrations. These are the third party ones. See here, Airbnb. This is provided by Airflow. This is also provided. Airtable is also provided by the community. Somebody like us built a MCP server and put it here for us that can be used. So if you click here, and then you can go openbnb.org is where if you go to releases, see here, .dxt. So this is your desktop extension. If you want to directly add to your desktop, you can just download this and then add it. It will be available here for you to add. Of course, from here also you can add from the cloud. So I will go here and okay, let's go back. Before we go here, let's go explore what this is. So Airbnb, advanced search capabilities. These are all the features. Location-based search, Google Maps Place ID, data filtering, guest configuration, price range filtering, pagination support, detailed property information. Okay. So for Cloud Desktop, you just go to releases and download this .dxt file from the releases page. Open your Cloud Desktop and install the extension through Applications Extension Manager. Okay. If you are using cursor, you can do this. Right, all of that. So see the tools here. The tools you have is Airbnb search. This is one tool, and these are all the parameters that it needs. Okay, and then there is Airbnb listing details. There is another tool, and these are all the parameters, and this is what it returns. So basically, there are two tools here that you can use when you use this MCP server. Okay, now if I go to this here, which I have already added. So Airbnb listings here. If I click this, you see these are the two tools, Airbnb listings details and Airbnb search. Okay. So if you switch off this, that tool is not available for the desktop to use. You can activate and deactivate, or you can disable all tools and all of this here. Any tool, as I shown you, you can go here, not tool, sorry, MCP server, manage connectors, and then here you can go and manage. So there is MCP Docker also I have implemented, but I think you can look at that. So let's say I have Airbnb listings here. Now I have enabled it. We'll go back go back here and then say, I want to book a, let's say, Airbnb in SFO, right? For next week. That is for a family of 2 adults and 2 kids. Budget is, say, 300 per day. Okay. The best options, and also check the weather alerts for the same. That's it. I don't want to give more information. Let's see what it is, right? So, Girish, so your use case, right? You wanted to check this. Now I have equipped this with weather MCP server, and it also has Airbnb MCP server. Both the MCP servers and the tools available. Airbnb options. Okay, first it has gone to Airbnb search and listings tool, right? So where is this? So come here. This is listing details. Airbnb search. Airbnb search and listings. It wants to use. And then see the request it has formed. Location is San Francisco CO, address children, max price, check-in, check-out. It gave based on my information, whatever is available. So I will do allow once. I will find the BNB I stand for your family and check the weather alerts for California. So it also added that request since it is there in our request. So first it is checking for the accommodations. Look at this. So we have Airbnb search listings again. It is asking. I said, okay, fine. Go ahead. Airbnb search. What are good Airbnb options? See, now it has gone to get alerts from weather. And state is CA. We just said SFO, but it has already deducted all of that information for us, and it built a request object to send it to the weather. So this is our own MCP server. This is the third-party server Airbnb that we are using. So both of them, and then it gets got this.
It is not checking for the particular date that we feed it, right? It's because we didn't have that in our tool, right?
Yeah, it's just the current weather alerts as of now. What are the weather alerts? Because that particular API is not taking dates as request parameters.
Right.
If there is another API that takes for a future date, and then we create that tool, expose that, then it will automatically should use. Yeah, so these are all the options that it came up with. And then it has added the weather conditions. Okay, whatever it is. Right now it found until 2 p.m. Saturday and all of that. Okay. For your next visit, most current alerts will be cleared by then, but always check before beach activities and all of that. So we also gave a recommendation for bedroom, family, heaven, and all of that based on the budget. So this is all of it. This is how step by step it resolves. As I'm, but if you want to book the complete vacation, so it can iterate through all of that and give you the best recommendations based on all the inputs that you give. I gave only the number of people and number of for a week, and then budget per day. Now I can add it what are all the activities that I'm looking for, or a particular location that I want to be close to the local transit, or close to airport, or close to the beaches. So I can provide all those inputs for it to process. Okay, so this is now we have added both. Okay, the MCP servers. Now if we can go manage connectors, extensions, browse extensions. So these are all the ones that you can check. Okay, which ones, whatever is convenient to you, you can connect and verify that. So web extensions. So you have Google, you want to connect to your Gmail. You can ask questions about Gmail inbox once you authenticate and give information from here to connect to Gmail. Use the data to respond to your prompts when appropriate. Summarize my inbox, so it will access your inbox. You retain control of your Gmail data at all times. We do not share your Gmail data with anyone. You can delete your conversations with Claude. Delete any Gmail data Claude used in that conversation. Okay, so you can go ahead and try some of these MCP servers. But these are just web connections. So just the tools. I don't think these are MCP servers. These are the ones that says MCP server, dockling MCP, and all of that. It says where it is an MCP server, you can use that as an MCP server. Otherwise, if it is a tool, it can directly connect from the cloud directly to the tool, like we were doing earlier. Now, another one is the Docker tool. So Docker has like the same thing. If you have Docker, you can, so if you have latest, I think most of you have worked with Docker, right? Docker desktop, Docker. So there's a new feature called MCP toolkit in the Docker, where it gives you all the available MCP servers that it manages. Okay, so instead of directly adding yourself to the client, you can connect both your server and clients here using this catalog. So in this catalog, you have Playwright, Postgres, DuckDuckGo, MongoDB. So you can connect any of these MCP servers here into this. And then it can reach out to that MCP server from your client when you connect both of it. Okay. So let's see here, we have Perplexity, Tavili, all of this. Okay. Arcsif. Okay, let's take Arcsif MCP server. So it has like 4 tools: download paper, list paper, read paper, and search papers. Okay, these are all like just for your research papers. The repository. Now what I have done, I have already added one server called YouTube transcripts. So it has 3 tools: get time transcript, get transcript, and get video info. Okay. And in the clients, I go to clients here, there is Claude Desktop that I have already added to the MCP toolkit. So basically what I'm doing here in the Docker desktop is I'm connecting my server and my client through my Docker. Okay, so when I go to the Docker extensions here, I should be seeing MCP Docker. So this is what you will see here. You will not see directly your YouTube MCP server here. It is MCP Docker. Now, when you click on the tools, then it will consolidate all the tools. See, get time transcript, get video info. All of these are available here. Okay, so I have done this here. So I will again take the same thing, come back here and give this prompt. I want to generate a transcript for this video, okay, YouTube video. So I can run this. So this is the request from MCP Docker it is using. This is the request, youtube.com. So if you allow it once, or if you allow it, it uses get transcript method, and it goes through that video and gets the transcript summary. Comprehensive GenAI training transcript content, retrieve the transcript. So it talks about participant introductions we have done, different locations, evaluation of all. So this is about what was discussed in that session. The transcript appears to continue beyond what was. Would you like me to fetch the remaining portion of the transcript? It just gave some of it if you want more. Okay. And
Arun, sorry to interrupt you. I have one question here.
Mhm.
So when we integrate with the Docker desktop, will it create actually any container, or actually how the execution will happen within the Docker?
Yeah, it's a container image, right? So if you are here, this is the image that it creates.
Oh, okay.
For MCP YouTube, it will run when you are running that from your desktop as MCP server.
Oh, so then the container will run as MCP server in that case.
Yes.
The cloud will connect to that MCP server.
Okay.
Oh, got it.
Yeah. Okay. So if we come here, we get this. Now, we want to check another tool. Get the time transcript. So this is the summary of the transcript. Now let's say I want to get the time transcript. There is another tool. Okay. Identified request and mobilized transcript retrieval function. Get time transcript. This is calling this function. Now if I allow once, what it will do now is it will not summarize. It will give you checkpoints like at each timestamp what was happening with that video. Share session introduction for 431 content begins. With each time what happened, it will start generating all of the time tokens. Okay, so that is how we use all of this MCP. Of course, I have shown you the high level of what functions, how you integrate MCP into your client. The same what we do here can be done from any of your application, as long as you have this configuration for your application MCP server. You bring it up and then run this. Okay, so that's about the MCP. I will share all the recordings, and then you can play around with any of this. Any questions?
And Arun, sorry, Arun. If you go back to that the slide that you had when you started the MCP server introduction, right? If you go back to that one very quickly.
Which one?
You had that slide open, right? That was slide or that the architecture flow.
This one?
Yeah, this one. Yeah. So here, I think there was another slide. Oh no. So go back to the go front ahead. Yeah, a little bit more. Next one. Yeah, this one here. So here, this is the MCP client agent, right? And then the remote agent is also so when you say client agent, okay, so the
remote agent is somebody else is exposing another agent for you that can do the job. So you can call that remote agent using A2A protocol.
And they don't need to go through MCP, right? I mean, we can call an external agent who is not going through MCP protocol.
Agent to agent will not go through MCP protocol. Agent, if you want to, you see here on the right side, if you want to execute anything, then it will use the MCP protocol.
MCP protocol. Okay.
Yeah.
But then we will have our own MCP. The agent, all the things that we created, the prompts and other things that we gave, right? That was also an agent, right? I mean, technically, we were. That is an agent that is calling other agents, like whether it is Airbnb or the weather.com. Those are multiple agents within the agent framework.
Those are MCP servers, Airbnb and weather.
Oh, okay.
Okay. So the agent is your Claude. This is your agent. This Claude is your agent.
Claude is my agent. Yeah. Got it. Okay.
And these are all your MCP servers or tools. So these are direct tools that the agent is using, and these are the MCP servers the agent is using. Airbnb, MCP Docker are the MCP servers that this agent is using. These are the web search is the tool, direct tool that this is using without MCP here.
Got it. So now if you go back to that picture or the architecture, so the agent is calling the servers and then the tools.
The tools are within the server.
Yeah, okay. Perfect.
So the servers will expose all the tools and the agent can invoke any tool from that server.
So we need to invoke these tools in our custom LangChain code, right? And now we used Cloudy to call these tools. So can you show us the code how we can invoke these tools within our
You don't invoke, the
LangChain?
agent will take care of it. You just you don't need to, right? So once you have the server configuration in your agent, the agent will take care of calling which tool you want to call.
Yeah, in the agent, we develop our own code, right? The agent code.
Yeah.
In that, I want to see how we can invoke this instead of Cloudy.
Oh, instead of Claude Desktop, you want to see how the application can call the
Yes.
MCP.
Yes.
Okay.
You add some library. Yeah.
Sure. Yeah. Next session, we can try that.
Sure.
I will come up with the use case, how to get that, and then we can go through and verify. If not tomorrow, maybe next week or sometime, we can definitely continue doing our whatever is backlog we want to see. Use cases we can build. Okay.
We are not going. Yeah, we are not going to do anything with the A2A, right? Protocols for MCP.
Not now. Not right now. It's just an internal thing that agent, the frameworks implement for the communication between the agents.
No.
Mhm.
Hey, Harun, I have one question actually.
Hey, Nitin. Yeah, tell me.
Yeah. So our company has started using Gen AI, and means like the architecture team and everyone they're trying to enforce using more on the MCPs than agents. So what is the current industry standard? Because we went through all the course, right? We went through generative AI, LLM, vector data, but I don't see that use cases. Maybe it's specific to our organization. I don't know, but the way that looks like they're enforcing us to more use MCP, and we started developing one use case and doing that. So as per your industry's trend, because we are working on agentic AIs, and you see here MCP is now there, and traditionally open AI will be coming up more models. They keep on updating their models. So where do we stand? We don't even need to do any more kind of doing semantic search or creating over our own LLMs or increasing more on that area. So where do you see the industry standard is going towards now?
It's a good question. Let's come back and see what we have learned, right? We have learned all of this: prompt engineering, embedding models, vector databases, RAG, and agentic AI, multi-agents, right? Deployment and all of this. And now we're talking about MCP.
Right.
Now, when you said our company is asking to focus more on MCP rather than agent, I would not agree with that, because MCP can only be used with agents. Okay. So all of these, whatever you have learned, are all part of the same architecture. These are all complementary. You cannot use one in place of the other. Okay.
Correct.
Of course, you can use, see here, I have Agno, I have Langflow, I have Bedrock, and I have Crew AI. You can choose one of these. That is alternate. Instead of this, you can use this. Instead of this, you can use this. Okay.
I think
But
we
I
are using
cannot-
Amazon Bedrock. Yeah.
Yeah, but you cannot use an agent instead of RAG. That does not work. I'll tell you how would you connect all of that, right? So now you have learned all of this. Let's go back to just say RAG. I think here we should have that. I keep missing that slide. Anyways, the multi-agentic RAG, right? So you see here, this is the RAG. Okay. Now you don't have an agent here, correct?
Right.
So this is completely a RAG where your input is coming in to the model, and the model has you're doing RAG augmentation, getting it responses and sending to the model. Now, suppose this entire RAG is built in a tool. You create a tool, and within the tool, you are calling this RAG application, which means the tool will take the user question and then pass it on here. Okay. And then this will all run and give you the response, right?
Right.
You fit that in the RAG as a tool. Now, the tool is part of the agent, right? You can add the tool to an agent. Now, when you ask a question to the agent will use the tool. The tool will invoke RAG, and RAG will connect to your internal database and get you the information. So that is how you use agent with RAG as a tool. Now, put the same tool into a MCP. Now, your agent uses an MCP server which has a tool that can run the RAG and give the information out. Now you connect all the dots, right? So your front-end chatbot application or a external thing, whatever a user asks a question, give me all the invoices that are pending for over a month. Okay, for a city or for whatever. That's the question. Now, how do I design that architecture? Okay, so let's say Let me get this. Get this. Where is this file? In a spreadsheet.
So if I can take a stab at that, right, while you're pulling that, right, Arun? So
Yeah.
for opening, you're asking a question on get all the invoices for, say, a department A, right?
Yeah.
For that month, right? For department A. That is the agent is the one that is agent is the one through which you can ask that question. The prompt is that getting the pending invoices, and then you're going through the RAG application to connect to the database, right, and pull that information and display it back to the end user, right?
Yeah, that's correct. Now, if you want to dig deeper here, so where is my this pending invoices data? So I have an invoice database, right? So database where I store my invoices, and it has a status pending or whatever. So you will have that. Now I build a RAG application that will connect to this invoice DB and get the results out. Correct? So there in the RAG, you send the same this query as a prompt. Okay. In the RAG, you send this as prompt, gives you result. Now this entire thing, what you want to do is you create a tool. You just call a RAG underscore tool, which will invoke your RAG with the same prompt. Correct? Can you do this, Anna? Okay, right now what we are doing, we are just doing from the chatbot, whatever query is coming, we are sending here to the RAG. Correct? The same thing, the moment the query comes in, we call the RAG tool with the same prompt. So that tool will do all of this. That we can do.
Yep.
Right? So this is my tool.
And tool is nothing but the API call.
Yeah. API call, you have all of this RAG, or it need not be API, it is an internal function. It just have to, all of this code, whatever you are building here, this entire thing, this RAG we built, it can be running on a server on API, or it can be just a function that you call from this. It will run as part of the same application. Okay. So now you have this tool here. Okay. Now I connect this tool to my agent. Right? I can do this. Okay. So now my agent and tool. So I give this tool to this agent. Now, when I ask the same question to the agent can choose the tool, and that tool can run this RAG application and give you the results. Are we all agree on this?
Yeah, that's correct.
Now, today, what we said, hey, instead of connecting the agent to the tool, we will put an MCP server and define this. Yeah, we define this tool within that MCP server. And now, once I register this server, my agent knows, hey, I have an MCP server. It has this RAG tool that can give me this RAG data from this invoice DB all the way back. So what I will do is I'll take this prompt, go to the MCP server and use this tool and send this prompt as a request and get the results. Right? So now all of these components are connected.
Yeah.
Okay, so this is how your architecture can be. So now you are not using MCP server instead of agent. You are not using a RAG application instead of MCP server. Rather, these are all individual components based on your use case. You can connect all the dots. This is the end-to-end frame. Now this entire thing, you go and deploy using Fast API or Lancer or LangGraph Studio or any other Bedrock Studio, anything, you build everything and you deploy. That whole thing can put into a container, Docker, and scaled using Kubernetes. So you can build the components, stack the components to build the entire scalable architecture. But if you go at the lowest, deepest grain, this is where it lands. This is where your data actually is. Okay, so this whole thing, you are building the architecture for the agentic AI. So tomorrow, once I get this invoice, okay, let's say send out an email to the customers. So let's say I will add and send email to customers for invoices, pending invoices. Right? Now, you're just not just getting those invoices, but you also want to send an email. Now, to send an email, what do you need? You need to connect to one agent email server, right? So we have seen there is a Gmail here. Now I have another tool, let's say called Gmail, or your company email. For example, I'm just taking, let's say, Gmail as an example. Okay. Now this is another tool. So I can have another MCP server here, which has this Gmail tool. Now, once this get information, now this can invoke another MCP server and send out Gmail to all of these clients with whatever prompt you are sending. So that all of that you can add. So what you want in the email address, attach the invoice details, right? Attach invoice details and make tone formal and mellowed. Do not use some kind of harsh language, whatever. So it takes all of this, it invokes another MCP server, takes inputs from this, and then if it is integrated with the Gmail, it can call this tool, connect to your inbox, use the email IDs, and then send out the emails. So this is the extension to this use case. So you can have as many things. So this can also be another agent, which has this MCP server. Now, how do these two talk? Now, this is where it gets interesting, right? So you can actually agent 2, email agent, has this MCP server. Now this agent gets all the details. Then it figures out, hey, I have to send out an email, but I don't have access. Then it looks out for another agent, let's say with A2A protocol. And then this email agent publishes saying that, hey, I have an MCP server. I can send out emails using Gmail. Now this agent can delegate. Okay, now I have this information, take this information, and since you have capability to send email, send the emails using this information. So this can play out with A2A protocol between these two agents. So just like your company may have one email agent created, that is purely can be used to send out emails. Right? Yeah, Nitin, you have a question? We are almost 20 minutes past. Yeah. Hello? Can you guys hear me?
Yeah, we hear you, Harun.
Nitin, you raised your hand. Do you have a question?
No, I was the one who asked it actually, so I'm good. Yeah.
Arun, just one question, sorry.
Yeah.
Some of the data feeding through a vector database and sending to LLM, and some of the data we can get it through tools. Like we can expose our own data through the tools as well, right? So what kind of data we have to feed to vector database and that can be sent it to LLM, and what kind of data we can use tools to fetch and send it to LLM?
So tool is just a definition. Okay, inside that you write your code. Now it can be a semantic search with vector database. Vector database mostly will use when you have unstructured data. Basically, if you have a PDF documents or Word documents or anything, and then you want to extract information from that based on a context search, you use that. If you have a structured data, you can just use database connectors within the tool, like Snowflake. If you have, you can write a tool just to connect to Snowflake and send out the SQL query and execute that query and get the results back. Okay, so invoices can be a structured data. You build a view with all the pending invoices. You just call that view from the tool. The agent will call that tool. The tool will execute that SQL against Snowflake and then get you the results in a tabular format. So it's all use case to use case. You have to make a judgment where I need a vector database, where I don't need. If your invoices, they are all structured data. Mostly you don't need a vector database. All you need is a indexed, highly performant view where it can return based on the query. Now, how do you generate that query? Yes, that can be an LLM thing based on the text to SQL capability. It has to know which table it has to go, or you can hard code the query and it will know which tool to use for that particular query.
But structured database, it won't work like a vector database. Like it won't find the relevant
It will
information.
not. Yes, that's the whole point, right? If you have a structured data, you write a straight SQL where, so let's say in this use case, invoices pending and date greater than 1 month or something.
Okay.
So you don't need a vector database, you don't need embeddings, and you don't need a semantic search there. But if it is a text data, like legal data or HR policies data or whatever, you want to score through all of those documents and get the relevant information. That is a good use case for your vector database.
Yeah. For the structured database, not to query, I need to know exact column because I need to hard code those column names. But in case of vector database, it automatically knows which column it has to query.
In vector database, you only have one column, right? You don't have multiple. It just gives you a text.
Correct.
Yeah.
But in structured base,
there is a lot of code LLMs. Like if you take Databricks Genie, right? It has Genie completely works on the same framework, like text to SQL. You write a question, you attach all your metadata, your tables to that workspace. It knows which column has which data, which table has what data, what are the joins between those tables. Based on the query, it can read, join the tables, form the query, run the query, get results, put it in a dashboard, and display the visual image of that query. So that's the platform. Text to SQL, chat with your data is the popular use case with most of the organizations, the C-suite or leadership executives. They want to have that capability, chat with your data. They just want to type questions in English and they want to see results in a tabular format or in a visual format, kind of thing.
Okay, that framework we can use it to query the regular RDBMS kind of
correct
structure.
Yes.
Yes. Got it.
So yeah, look up that chat text to SQL use cases or chat with your data use cases. Specifically, Databricks Genie is pretty popular in that space.
Sure. Thanks. Yeah.
Okay. All right, guys. Thank you so much. We spent a lot of time. I hope this was helpful. Okay. Let me stop sharing.